Okay, we're back, and I am going to share what I got with my data. Now, full disclosure, yours might be quite different depending on your data. But here we go. This is what model 1 looked like, where we just have our standard x on the x-axis and our standard y on the y-axis. This is what my residual plot looked like. This is what model 2 looked like, where I have x squared and y. Careful when you write your equation, okay? Because we're no longer dealing with x here, we're dealing with x squared. So it should look like y hat equals a, whatever your y-intercept is, plus b, whatever your slope is, times x squared. And then this is what my residual plot looked like for that model. Finally, model 3, I have x on the x-axis, and then I have the log of y on the y-axis. Again, be careful when you're writing your equations, because it should look like the log of y hat equals a plus bx. And this is what my residual plot looks like. Okay, how do I choose the best model? Well, there's several things we're looking for. One thing we can look at is the residual plots. And we're looking for the residual plot that is the most random. And I would have to say it looks like this one is the most random of these options, okay? Then this one I can see is kind of slight pattern. It's very faint, but this one is the most random. The other thing we can consider is how strong the resulting relationship is. And in this case, this one in the middle, model 2, for me, had the highest r and r squared value. So for those reasons, I'm saying that model 2 is the best model. It has the highest r squared value, and the residual plot shows no pattern. Now, for you, you might have ended up with something different. I don't think I had a lot of people end up with model 3 in my other class, but some people ended up with this one just being the best model. So it just depends on your data. Pick the model that fits your data the best. Finally, it says calculate how many inches you will have to pull back your car to make your car travel 5 seconds. This is a y value, so plug that y value into the left-hand side and do some calculations. We end up having to do the inverse of the square to sort of unwrap our x, so it's not x squared, it's just x. And I got 15.546 inches. Again, yours might be quite different depending on your data. But this is the kind of thing you might be asked to do on a test. They might give you several different types of models. They'll show you what the scatter plot looks like. They'll show you what the r and the r squared value is. They'll show you what the residual plot looks like. And then you're going to be asked to choose which model is the best model. Okay, let's take some quick notes on the top of the next page. So now we're at the top of page 27, and we're going to take some important notes. Okay, so the first thing is just the general idea of transforming data. What do we mean when we talk about transforming data? It is what we do when we have data that's not quite linear. So if a linear model is not appropriate, we can re-express the data by applying some kind of operation. So oftentimes that might be a log. It can be a natural log. It can be a square root. It can be a square. Some kind of operation to all the values in the data set. With the hope of making our data look and act a little bit more linear. Okay, so what might you be asked to do? The first thing you could be asked to do in the context of transform data is to choose the best model. So when choosing the best model, there's 3 things that you can consider as you make your choice. The first thing is check the scatter plot for linearity. Does it look linear? Which one looks the most linear? We can also check the residual plot to make sure there's no leftover pattern. Look for the one that looks the most randomly scattered. And we can check our R-squared value, looking for the one that is closest to 1. So it's the strongest one. So you almost certainly, I can almost guarantee, will get a MC where you're given a few different models and you're asked to decide which one is the best one. The other thing that you will certainly be asked to do, probably on an MC, usually these 2.6 type questions are going to be on an MC, not an FRQ. So I'm going to scroll over to here now. The other thing you might be asked to do is to make some predictions. And we're already pretty good at making predictions. We know the way to do that is to plug in a given value for X and to solve for Y. It's just a little bit more complicated when you're dealing with transform data. So for example, if you have some data that looks like this, log of Y is equal to your y-intercept plus your slope times X. Well, you can plug in your value for X and then you get some kind of number over here. But whatever that number is not your final answer because we still need to undo this log. So the way to undo the log is to raise both sides to a base of 10. That undoes this log. And then in your calculator, you put 10 to the power of a plus bx, whatever that number is. And that's your actual predicted y value. Another thing you might see is the natural log of y hat equals a plus bx. The natural log is very similar to the log, except instead of having a base of 10, we have a base of e. So if I want to sort of unwrap this y, I need a base of e. So raise both sides to base of e. That will cancel that out. And then in your calculator, put e to the power of a plus bx. By the way, your calculator stores e as a value. It lives, let me get out of this. It lives right here over the division symbol. So if I want to get e, hit the second key and then the division sign. And then you can, find e to the power of something. Now, last example I'll talk about here is if you have like y squared equals a plus bx. Well, the inverse of y squared is a square root. So we might need to take the square root of both sides in order to, again, kind of unwrap and unveil the actual y. Or I should say the actual predicted y. Okay, pause this video and try this check your understanding problem. So pause this video for about 5 or so minutes and have students try these 2 check your understanding problems. Okay, we're back, assuming that you have tried these two check your understanding problems on your own, and now we're ready to talk about the answers. It says, use each model to predict the life expectancy of residents of a country for which the average annual income is $80,000. So we're going to do this for every model. So let's start with A. A is just kind of basic. We just have y equals a plus bx. So hopefully everybody got this one. You should get y hat equals 69.9352 plus 0.1530 times 80. And you should get 82.2 years. That one is kind of standard, okay? No transformation going on there. The next one, we have the natural log of y hat equals 4.2436 plus 0.0021 times, and again, we're going to plug in our x value of 80. Okay, here, what you get when you put 4.2436 plus 0.0021 times 80 into a calculator is 4.4116. Now, this is not our answer. Okay, for one thing, it makes no sense in this context, so that's a really good clue. But for another thing, we have our y currently being wrapped by this natural log, and we need to unwrap it. And the way to unwrap it is to raise both sides to the base of e, because that's going to cancel out that natural log. So what we need to do is calculate e to the power of 4.4116. So let's do that. So how that would look in our calculator is e to the power of 4.4116, and we should get 82.4. And that is a number that makes a whole lot more sense in this context. Okay, C is probably the one that a lot of people were confused about, if I had to guess. Because we have the natural log around the y value and the natural log around the x value. The great news, though, is when we plug in 80 here, the natural log of 80 is just a number. So actually, we're not doing anything too different from what we had done before. So we're going to have the natural log of y equals 4.1393 plus 0.0603 times the natural log of 80. Now again, when you plug this into a calculator, what you should get out is just 4.4035. And then once again, we have one final step. We got to take care of this natural log. So we're going to raise both sides to a base of e. So that cancels out, and we're left with just y hat equals e to the power of 4.4035. So let's calculate e to the power of 4.4035, and you should get 81.7. And there you have it. Finally, which model will make the best predictions for life expectancy? I said Model C. 2 reasons. First of all, when you consider these scatter plots, I can see a faint but existent curve in these two. This one is pretty darn linear. I'm not seeing a pattern here. And the same thing is true of the residual plots. I can see a faint but existent curve in these two, but nice random scatter here. So that's what I'm going to say. Model C. Because the scatter plot is the most linear and the residual plot has no leftover pattern. And there you have it, folks. These are the kinds of questions you could get asked. Making predictions with transformed data, choosing the best model. These are not that hard, but people often get these wrong on a test because they're just flying through the test so quickly that they literally just don't notice this. And so they plug in their X value here, they calculate it, they get 4.4116. They see that 4.4116 is one of the possible multiple choice answers, and they're like, yep, that's the one. And they totally don't even realize that that natural log was ever there. So be on the lookout for those, folks, because you can do it if you notice that it's there. Okay, our last page that we're going to do together today is going to be 29. 29 is just some algebra practice. So we're going to practice finding the predicted y value with this x value. So for all of these models, plug in x equals 10 and get out y hat. You're going to use varying levels of algebra for all of these. So again, go ahead and pause this video and give students about 5 minutes to complete these problems on their own. Okay, we're back. Let's talk about these problems that you just did. Okay, the first one, very straightforward. Don't even really need any algebra for this one. Okay, because when you plug in 10 here, the natural log of 10 is just a number. So when you add 2 plus 0.8 times the natural log of 10, you're just going to get a number which should be 3.842. This one, we do need to do a little bit of algebra. So plug in 10 here for our x value. 3.5 plus 0.7 times 10 gives us 10.5. But 10.5 is not our final answer because our y value is wrapped up in this natural log. So what we need to do is raise both sides to a base of e, and that cancels the natural log there. And we're left with e to the power of 10.5, which gives us 36,315.5. So, okay, one thing you need to memorize for the test is that the inverse of natural log is exponential with base e. So natural log and inverse, the natural log and base e, they're a pair. Speaking of inverses that you need to memorize, the second one we have, instead of the natural log, we have the log. Here, once again, I'm going to plug in my x value of 10. What I get from 5 minus 0.23 times 10 should be 2.7. Not done yet. I got to unwrap my y by raising both sides to a base of 10 to cancel out that log. And I end up with y equals 10 to the power of 2.7, which is 501.19. Another thing to memorize, okay? The inverse of log is exponential with a base of 10. So 10 and log are a pair. Finally, not finally, we got two more. Okay, plug in 10 here, and we need to use some algebra to get to y hat, and you should get 2. By the way, I just stopped here, excuse me, hold on, let me back up. What we get here is 0.5. At this point, we can multiply both sides by y hat to cancel that y hat, and we get 1 equals 0.5 y hat, or y equals 2. If you are a very lazy mathematician, which I sometimes am, you could stop right at this point. Notice that if 1 over y hat equals 0.5, then y hat must be 2. But again, algebra will get you there one way or the other. Last one. We have x in multiple places. So we need to plug that 10 in everywhere x appears. So here we have 0.8 times 10 squared minus 1.2 times 10 plus 1, and you should get 69. And that's it, folks. Algebra. We love doing algebra in stats class. At least I do. Oh. Okay, dokie. So this is what you'd be expected to do in terms of 2.6. Be able to make predictions. Be able to choose the best model. Okay. That's it for today, folks. I'm going to tell you your homework. So, last homework of the unit. The next time I see you is going to be the 9th of October. And you're going to finish the rest of this section. So, I believe it's 30 through 32. So, page 30, 31, and 32 is your homework. You should have a decent chunk of time to do your homework right now. Also, I'm going to have the guest teacher pass out your review packets. So those of you who are just really excited for the Unit 2 test and can't wait to get your hands on the review packet, you're going to get that today. We still have one more day left of class before the test. So in class on Thursday, we will spend some time focused on the review packet. But I have it printed, so I'm going to give it to you early. And that is that. Use the rest of class wisely. I would suggest starting with your homework, and then if you have time, moving on to the review packet. Thank you very much, and I'll see you on Thursday.